Okay, we're back with Lab 1, the calculation portion. You can see that I created a table to note down the masses of my two sample sets. For sample 1, we have masses of 60, 70, and 50 grams. Sample 2, we have 40, 60, and 40 grams. So what I'm going to do is show you how to find an average. This might be familiar to many of you. And then an average deviation. So what we have to do to find an average, we have to add together our three numbers. So for sample 1, we're going to add 60 plus 70 plus 50, and that will make 180. The next thing, after you have the sum, that's the sum, you have to divide the sum by the number of samples. So in my case, I used 3 samples, 3 replicates, and in your case, you will be using 5. So your number will be 5. So now I'm going to divide 180 by 3. So my average mass here is 60 grams. So I made a little table here for myself to fill in. So I'm going to write my average here. You'll notice your data table in your lab book is set up very similarly. Now next to that, the column next to averages is the deviation. So if you can see, if that will focus, the deviation. And that's in brackets because we use the absolute value, always a positive number. So deviation is nothing more than the difference between your measurement and the average. So here, our measurement was 60, the average was 60, the deviation is 0. Here, our measurement was 70, the average is 60, our deviation is 10. We're 10 units away. Our average here, our sample is 50, our average is 60, so we are still 10 units away. Notice both of these are written as positive numbers. Even though our sample is 10 units higher than our average here and 10 units lower than our average here, the bottom line is that both of them are 10 units away from the average. It doesn't matter, positive or negative, we write it as a positive value. So now the average deviation, if we average together 0, 10, and 10, we do that similarly to how we found our averages before. So average deviation, we're going to add together 0 plus 10 plus 10, and that makes 20. And we're going to divide, just like before, divide our sum by the number of samples. So 20 divided by 3. So we can do this out on paper, or you're welcome to use a calculator. It's like we're going to get 6.6 repeating. So let's round. Since both of these only had one significant figure, you're going to be talking about that a lot in Chapter 2. Let's keep 7 as our average deviation. We're going to round up because this 6 is greater than 5, so this will round up to 7. So in the end, we can say that this sample 1, which was our yellow peas, had an average of 60 grams and an average deviation of 7. And the way to write that will be, I'm going to write it here, sample 1 weighed 60 plus or minus 7 grams. And what that means is that this sample could weigh as much as 67 grams, that's the high end, or as low as 60 minus 7, which is 53 grams. So this 53 to 67 is what we call the range, and ultimately if the two samples' ranges overlap, we'll be able to say whether or not the two samples are different from one another. So let's look at sample number 2. we can find our average using the data we had, 40, 60, and 40. So the average will be, we have to find the sum, which is 140, and we have to divide the sum by 3. And it looks like it's going to be 46.6 repeating for the average. So again, because each of these had one significant figure, remember the 0 doesn't count unless there's a decimal after it, we will say that our average is, if we keep one significant figure, that'll be the first here. This 6 will round up, so our average is 50 grams for this sample. And we need to find the average deviation as well. So let's write in our average, 50 grams, and you'll see on your data table there's a spot to put average or mean. Those two words mean the same thing, average or mean. And there's a spot for deviation. So again, deviation is the difference between your sample and your mean. So the space between 40 and 50 is 10. The space between 60 and 50 is 10. And 40 and 50 is 10. So if we were to average these three numbers together, what would we get? Basically, the sum of 10 plus 10 plus 10 is 30. Divide 30 by 3, and we get 10. So anytime you have three of the same exact numbers, you know that the average is going to be that number, because an average best represents your sample set. If the sample set is all the number 10, you know the average is 10. So our average deviation is 10. Okay, so we've just determined that our average deviation is 10 for sample 2. So if we want to write that out, we can show that our sample on average weighed 50 grams with a standard deviation of 10. So now we can compare our two sample sets. Sample 2 weighs 50 grams plus or minus 10 grams. That represents the error margin of our samples. And from this, we can write a range. So just like we did before, we add 10 to 50 and we subtract 10 from 50, giving us a range of 40 to 60 grams. So notice that I write this low to high, a low number, a dash, and a high number. Just like we were talking about time, if let's say I work from 9 to 5, you would write the low and then the high number. That's how we write a range. Okay, so now we can finally compare our sample set. So I started drawing a number line here. So overall, it looks like our samples fall within the range of 40 grams to 70 grams. Sample 2, on the low end, could weigh as low as 40 grams. Sample 2 were the split mung beans. They weigh in this range. Sample 1, the yellow split peas, weighed between 53 and 67 grams. So if we want to draw that in, we can show, we have to estimate, somewhere between 50 and 60, that would be about 65. And so we're starting around 53 and going up to about 67. So this would be our range for sample 2. So sample 1. Sample 2 is here, and sample 1 is here. So now the big question that we finally can answer, which is what we set out to do in our lab today, is, were these two sample sets significantly different from one another? So this is the range that the yellow lentils can weigh. This is the range that the green lentils can weigh. So we have to ask, do they overlap? And they do. So we can see sample 1 has masses in this range, sample 2 has masses in this range. Because they overlap, we can't very well say that these two samples are significantly different from one another. If we had a number line that distinctly showed one sample set, a gap, and then another sample set, we would be able to conclude, let's say sample set 1 was here and sample set 2 was here, we would be able to conclude that these two samples are significantly different based on the ranges not overlapping. If the ranges do not overlap, the sample sets are different. If the ranges do overlap, the sample sets are considered to be the same, or at least not different enough to be statistically different from one another. And that will help you draw your conclusion. So make sure as you fill out your data sheet, you answer the questions included in the lab. The last one in particular, you want to make sure you make a clear conclusion. For example, I set out to find if two types of lentils had a significantly different mass than one another. You would say, I set out to find if two different fill in the blank had a different mass from one another. And based on my averages and standard deviations, as well as my ranges, you'll have to refer to your actual data. You can say that you concluded the two sample sets were, you'll have to say, significantly different or not significantly different. So I look forward to hearing your results, to hearing about what you did for your experiments, and make sure that you upload a clear picture of your data sheet into the Dropbox on Blackboard, and also upload a video of yourself doing the lab, or at least some clear pictures showing the important parts of the experiment. So I look forward to hearing your submissions. Thank you.